Hello and welcome. Today we're just going to do a simple, straightforward example of a tangent plane calculation. So the function is going to be f of x, comma y. Let me get that better. F of x, comma y is equal to 5x squared plus y squared. Okay, again. And the reference point we're going to use, x naught, y naught, is going to be 1 comma 2, right? We want to estimate z equals f of 1.05 and 2.1. All right, so here delta x is going to be equal to 0.05, right? And delta y is going to equal 0.1. All right, so we've already got our first pieces of the thing that we want. All right, so of course our approximation is going to be equal to f of x naught, y naught, plus the partial derivative of f with respect to x at x naught, y naught, okay, times x minus x naught. This is also called delta x, and plus partial derivative of f with respect to y at x naught, y naught, y1 minus y2, or y0. Okay, otherwise known as delta y. All right, so the first thing we have to do is compute f of x naught and y naught. So again, this is the formula we're going to use, and we're going to approximate what this function is at that point. All right, so what we want to do is figure out what this value is here, that value there. We're going to estimate it using the linear approximation. So this is going to be f of 1 comma 2. So that's going to be 5 times 1 squared. Excuse me, sorry. Plus 2 squared. Okay, so that's going to be 5 plus 4 is equal to 9. Great. All right, so we have our first value. Okay, so again, we've been able to now pair those values up. Now we have to take that second derivative, that first derivative, and that's going to be the partial derivative of x of the function 5x squared plus y squared. And of course, the derivative of y becomes 0, and then we're going to get 10x out of it. We're going to evaluate this at 1 comma 2, and that's going to be equal to 10. All right, so that's our value for our partial derivative. Let me just circle that up in green. Those two are related. All right, now, finally, let's take the derivative with respect to y. And we're going to get 2y coming out of it. We're going to evaluate this at 1 comma 2, and that will give us 4. All right, so that gives us this value. Okay, now is a matter of assembly. Now let's put it together. Z approximation is going to equal 9, that's our first value, plus 10 times delta x, which is 0.05, plus 4 times 0.1. All right, so let's see if we can estimate this. So this is 9, okay, and I like to put these maybe into what is 0.05? Well, that's actually just 2 times 0.1. So one way of putting it is 0.1 is equal to 0.05 over 2. So what we can do is actually do this. Go 10 over 2 times 0.1 plus, and this one's going to be 0.4 there. I think we've got a good estimate of what this is going to be. That's going to be that's going to be 1/2 plus 0.4, like that. So we're going to have 9 plus 0.5 plus 0.4, otherwise known as 9.9. So that's our answer right down there. That's my z approximate. All right, so I hope that shows you how you can use it. I wanted to make this a really quick video of just a good old example of how to use approximations. I think this is a thing we can practice and build up very easily. It's an exam question that would be a very straightforward one. You just have to know this formula up here, the approximation formula, and know how to use it to compute those values. So this would be an excellent example of an exam question. All right, well, I hope that helps, and I'll see you on the next video.